Hello and welcome to another one of D's ADD videos. Today we're going to look at the equilibrium constant rules. We already looked at reversing an equation. When you reverse an equation, you end up taking the reciprocal of your Kc. If you multiply by a constant, you raise it to that constant. But this problem we're going to look at is what happens when we add two equations. We'll use the other two rules, but the main new concept here is when we add two equations, you end up multiplying their individual equilibrium constants. Okay, so we're going to take a look at this example here. At 25 degrees Celsius, these two equations have these humongous K values. Again, large K's mean mostly products because of the ratio of products to reactants. If it's a large K value, that means this is much larger, the numerator is much larger than the denominator. But if it's a small K value, it's going to be mostly reactants. Alright? Because when reactants are large, that makes the fraction get smaller because of the denominator increasing. So we got two equations here and here, and we're trying to create this third equation in orange from these two equations. So what do we do to these two K values? Well, it looks like first equation, what did we do? The CO2s are on the right side as well as the CO, so how about just multiplying by a 2, it looks like? No, a 1/2, sorry. Because it was a 2, now it's a 1. So we multiplied 1/2 by K1, right? Or our equation. So we actually should be raising K1 to 1/2. This is what happens when you make videos at midnight. Gives you the new K1. And that's pretty much it for that equation. But for the second equation, it's a little bit more elaborate, because not only did we multiply by 1/2, so K2 raised to the 1/2 to give me a new K2 prime, but we also reverse the equation. So what do we do when we reverse the equations? We take the reciprocal. Let me do that better. So 1 over K2 prime equals K2 double prime. And then finally what we're going to do is we're going to take the product of K1 prime times K2 double prime to get our Kc. Alright, so let's see it in action. So the first one, we had to take our 3.3 e to the 91 and raise it to the 1/2 power. When you do that, you should get 5.7 times 10 to the 45th power. So that was my K1 prime. And then when you do the second one, it'd be 3.3 times, or I'm sorry, it's the other K value, right? So it would be our 9.1 times 10 to the 80th, and that one was also raised to the 1/2, but then after we did that, you had to take the reciprocal of it. When you do that in your calculator, you get 3.3 times 10 to the negative 41. And that's your K double prime for 2. And we said Kc prime equals K1 prime times K2 double prime, which then gives you which is 1.9 times 10 to the 5th. Alright? So it's kind of like a puzzle. You got to ask yourself, what did I do to these two equations to get this one? And the first one, the CO2 went from a 2 here to a 1 there, so that was your clue. It was multiplied by half. The same kind of pattern happened with the H2Os, but it was on the other side. So not only did you have to raise it to the 1/2 power, you also had to take the reciprocal here. And then it's just a product of the K values. Alright? Hope that has clarified things. Make sure you practice, practice, practice. Thank you and have a nice day.